What is meant by displacement current? In this diagram, we can see a capacitor. The plate A is positively charged and the plate B is negatively charged. Whenever a capacitor is charged or discharged, the electric field will be acting from positive to negative. Here, a magnetic field is produced in this region, which moves along this direction, and a current is produced along the wire. That current is called conduction current. When a dielectric material is introduced between the plates of the capacitor, during charging or discharging of the capacitor, the magnetic field will act along this direction, and the electric field, because of this electric field, electric flux will be linked with the insulator or dielectric. This change in electric flux produces a current known as the displacement current, I suffix D, which also act along the direction of IC, along this direction. So here, we got to derive a small derivation based on displacement current. We know that by Gauss law, the electric flux is equal to Q by epsilon naught. We also know that the electric field is equal to electric flux per unit area. In place of electric flux, substitute the value of Q by epsilon naught by A. So we get Q by epsilon naught A. Cross multiplying, we get Q is equal to E into epsilon naught A. We know that E into A is called as electric flux. So in place of this, we are replacing that by electric flux phi suffix E. Now differentiating this equation on both sides, we get dq by dt, epsilon naught constant, d phi E by dt. So dq by dt is nothing but the displacement current, which is also equal to epsilon naught into d phi suffix E by dt. I think you must have understood. We know that according to Maxwell's ampere circuital law, the line integral B vector dot dl vector is equal to mu naught times the conduction current plus the displacement current. So substituting the value of the displacement current in this equation, we get the line integral of B vector dot dl vector is equal to mu naught of IC plus epsilon naught d phi E by dt. Thank you.